So my name is Mounir Boudraa, so I work at Shopify. And so my focus right now at Shopify is working on login. So I will explain you what is login at Shopify and what Shopify told me to do when I arrived in the company like 5 months ago. So login at Shopify is this. So it's very complicated. It's supposed to be like 2 fields and a sign in button, like we do for every apps. And actually, it's way more complicated than that. So when I saw it, I was like, what? I don't want to work on this. I don't want to maintain this. It's way too complicated. Like, if I have to change something, it will be a nightmare to change that. So I started to think about a new way to solve this problem. So this talk is about like my experience and what I end up to solve that in a way easier way. So the first problem to solve was I wanted something easy to test. So all the components, even the UI, so the business logic, all the UI stuff, I wanted an easy way to reproduce bugs, to fix them, if any. And I want something easy to update. Like, as you see, the diagram is pretty complicated. And if the flow needs to be updated, I want something easy to update. When I arrived, like, everything was still very fuzzy and blurry, so we didn't know what kind of flow we would have in the end. So I didn't want to update this diagram, and neither the code linked to this diagram. And I wanted to have a way to have like a global picture of what's happening in the code. Like, one of the common problems within Android, which is kind of solved now with a new navigation component, is like there is no way for us to see the global navigation and what's happening in the app. So for a newcomer in the app, like, there is a lot of time to take to dive a little bit into the code and understand the whole navigation stuff. So I wanted to solve this by having like the code being self-documented by itself. So like unique page with a source of truth. So for the sake of the talk, we're going to focus on the simple use case of login, which is like a simple login screen with different states. So the whole talk is about like how to manage states in the app. How many of you have seen the MVI talk previously in the other room? Great. So it's the perfect following on this. It's not the same thing, so be reassured. So it's more about the criticism of it. So a basic login screen is what? It's like basically 6 states. The first one is when we have nothing entered. Second one is when we type something and we're ready to hit the sign-in button. Third one is when you are loading something, like when we are tracking the credentials. And then there is like 3 possible states. Either we are successfully logged in, or we have an error, or we don't have any internet. So even if internet is kind of an error, here is a different presentation. So the first approach would to be used like Redux or MVI, the same way you saw that. So I will go quickly on this because most of you already seen the presentation. So basically, MVI is 4 components. The view, a view controller, which could be the view model in the Arch component. An action, which means like when someone is clicking on something. And a reducer, which is responsible for creating a new state. So basically, when we have an app, is almost displaying different states as we saw that. So the reducer is responsible for that. So what we have is, so yeah, let's focus a bit on the reducer just to understand that. So the reducer is basically a function, and nothing more than a function, or a method in Java, that take the previous state, an action, and produce a new state. And what is very important about it is like it's a pure function, so it's easily testable. And a pure function means that actually we only use the arguments of the method to compute the system without changing something somewhere else. Typically, here, on a simple addition function, we have the first one is pure, because it only uses A and B to produce a result. And whatever the number of times you can run this function, it can be 1 or 1 billion of times, you will always have the same result. With the second one, it's basically the same thing, but here we are printing the result somewhere. And this is not pure, because if we run this in the billionth time, maybe we're going to have an error, or maybe because of the print system. So that's the main difference. And it's very important for the register to be pure, because this is what guarantees the testability of the function and of the reducer. So let's go back. So here, this is like the screen first. So we have the user is starting to type something. Then we have like a user action. Then we go to the view controller. The view controller is just like forwarding the action, creating the action, sorry. So the validate field action. Then the action is passed to the reducer itself. The reducer will compute a new state. And the new state is basically like the button will activate now. So the view is giving back to the view controller and to the view, and the view is rendered. Yeah. Then next step, we sign in, so we hit the button. Then we have a click event on the Android system. We go to the view, we create an action, which is validate sign-in action. Then we go to the reducer. The reducer produces a new state, which is we are loading. Here, and we have the loading button displayed. And now we have a main problem, because actually we changed the view, but nothing happened. We just said like the reducer is a pure function, so it can have a side effect. And actually calling the backend API is a side effect, because we are going out of the system because we make a network API, a network request, sorry. So how do we do that? By managing side effects. So side effects is like a complicated word for something very easy. Is just like going outside of the function. So if you want to make like a DB call or a network call or whatever, or log something, it's a side effect. So a side effect takes an action. The main difference, like it takes an action here and do whatever we do on the background thread. So typically here, checking the credentials. And then when it's finished, it produces another action or can produce nothing. In case of log, for instance, if we want to log something, we don't produce anything. Here, we are checking the credentials. So we are returning a new action, which is like, hey, now we are signed in. So everything happens correctly. And we return this back to the reducer. And with this new action, we're going to say, OK, now we have a new state, so we can render the new view, which is I'm logged in. But it could be there is an error, or yeah, exactly. So or network error or no network connection. So this is basically MVI. So MVI, the main problem with that is, I don't know if you see what I mean, but we have a store. So this is like the main thing about the MVI is like we have a global store, which is the component that holds everything in your app. So typically, if you have a complicated app, it will contain all the data for all your app. This is like a global state. So we're going to have a state for the first screen, second screen, which is loading, can submit, has error, is network error. So every single Boolean flag to allow you to render the array properly. And what you do when you do that is actually you try to figure out what is the actual state. So it might be a better way. The other problem is also that you manage actions. So you can basically call a new action from everywhere in the code. There is nothing preventing someone that from a screen, like let's say from the logged in screen, to send an action to the reducer that says, OK, now try to log in someone. And it's actually irrelevant because we're already logged in. So we need to have like a mechanism to prevent that. And MVI doesn't contain that, so you have to code it by yourself. The same way, what is happening if while I'm signing in here, I click like 10 times on the button sign in? Like it will generate like 10 actions, and how to handle that. So I try to think about something different. This is called a state machine. So the main difference between a state machine and Redux is like a state machine contains the logic itself. So let's deep dive a little bit on this. So now the register is changed, and now it's called a state. So a state, the main difference is like instead of having the previous state and an action to produce a new state, now we have only an action inside the state. And which means like the action is held by the state. So you cannot call like an action that is not handled by a state. Typically, we will see that basically right after. So the state itself contains the logic. the action, and the next state that will happen. So how many of you have managed like state machines or have written state machines? OK, so maybe it's clear enough. We'll see that like right after. We will understand better. So the main difference here is like once we understand this, once we understand this, and it's pretty easy because it's the same thing. So all of this is what we call like a universal, unidirectional data flow. Sorry. So the whole flow goes in the same direction. So we have the same thing. We start writing something, an event is produced, then we go to the view controller that create the action, that go to the state machine. The state machine is doing the logic itself here and render the view the same way. Then we click on sign in, same thing. And we change the view, say, OK, now we are loading something. And here, this is the whole stuff. Now we need to check the credentials. So it's done within the state itself. And it returns the next destination, which is I'm logged in. So how do we implement that? So the state actually, so have the state machine, and when there is an action happens, we check the action, what it is, and then we call the next state, state machine.nextState, which is the valid state here. For the valid state, we have two different stuff. Either we want to check the fields, or either we want to attempt the login. If we want to check the fields, we just like have some bunch of logic on it. We don't care about it. And we call the next state from the state machine and say, OK, hey, state machine, this next state is this one, valid, default, or loading. And once it's done, we say, hey, now the next state is authenticated state. So what we can see here is like, actually, there is no way with this to have like a global picture in it, because the state contains the logic, and one state contains the next destinations. So we have answered one problem with MVI, is like, when MVI, you can have actions everywhere in the code. Here, if the action is not handled by a state, you can create it. It will be ignored, because only actions managed by a state, here, attempt login, will be handled. The rest will be ignored, so there is no code to write. So in this sense, it's nice. On the other hand, a state contains the next destination, which means like if we want to understand what is happening, we have to go through all the states to understand what is the global navigation or what is global state machine flow. And if we want to add something in the middle or to remove a state or swap states, it becomes difficult, because then we're going to have to go through everything again to be sure that all the links are still working. So either you have a very good test suite to ensure that, or to pray. And in this case, typically, which is a real use case at Shopify for login, just like imagine if we wanted to change something like in the middle right, and remove something and add something else. We would have to go through all the transitions here to be sure that nothing is broken, which would have been a nightmare, to be honest. So let's continue with that. Everything is clear for now? Yeah? No? You can answer, you know? So if you want to sum everything up, is what MVI is providing is something easy to find bugs. So because of the states, so we have states every time. So what we observe is a state. So you can do that with the RX or everything else. We don't care about the implementation. But in the end, what you deal with is a new state. In this case, it's very easy to debug, because what you have to do is only set the state in your app and see how it's rendered. And if there is a bug, you can see it like very easily. It's kind of easy to maintain because the architecture is pretty straightforward, and you have to deal only with 4 components. So there is not a lot of things to deal with, so it's really easy to maintain. If you want to add new actions, it's pretty straightforward as well. The reason why is because you just have to create a new action class that contains the data, and then you have a new action. So what you have here is you have a global picture of all possible actions with MVI, which means like if you want to see what your app can do and all the possible interactions of your app, you can see you can go in the actions class file, and you will see all the actions possible. So it's kind of an interesting feature of this, because for a newcomer, it becomes kind of easy to see what you can do. Not how it's done, though, because to have the navigation, you need to go through to deep dive into the code. But at least you have all the actions. A nice thing as well is like the business logic is very isolated in functions or side effects. So if you want to test them, then you just have to run your function with an input and test the output. So it's really easy to test because you have like to do assert. My output is the same as what I expected. Same for side effects here, because you can now only mock your API and just like run the side effect and see what is happening and test the output of it, and test the new action produced, which is very easy to test, because everything is now functions and nothing more. So you don't have to mock a lot of things, you don't have to deal with Android, you don't have to deal with whatever dependency, it's really easy. So the logic are very well separated. Cons. The problems is that when you want to render a state, is like what you deal with is actually Booleans. So remember the example in the MVI previous talk, if you saw it, is like you end up with a state with is loading, can submit, has error, error. So now you have to do, okay, if this is an error and I'm not loading, then I should display this thing. But if there is no error and it's still loading, then I should display loading. Otherwise, I should display the content. So it can become hard to deal with, because when you have a lot of attributes, then you actually try to figure out the new state, which is the problem, because it's exactly what we wanted to do. Because MVI focuses on the global state of the app and not on what you have to display at this moment. And the other problem is that we don't have any global picture. So the code is not self-documented. If there is no one who tells you how it works, then it's really hard to figure out by yourself, because you have to deep dive into the code, which we don't want to do, because we want like every newcomer to be able to start coding something like from day one or day two. And last problem is like, again, actions can be dispatched from anywhere, which is like there is no way to prevent that an actions is irrelevant at some point. State machine, on the other hand, what they do is like they have pretty much the same pros, because it's the same philosophy. We deal with states, so easy to find bugs as well, easy to maintain as well for the same reason, because we don't have a lot of components to deal with. One problem solved here is like actions are carried by the state itself. So there is no way you call an action that is not handled by the state. If it's not clear, we'll see this right after. And the page that you want to render receives a state already. So a state ready to render. So there is no if loading stuff or if I have an error. When you are in an error state, then you know that you have to display an error. There is no code to try to find the state, because the state itself is self-explanated. A cons, though, is like if you want to add new states, if it's at the end, it's easy, but if it's in the middle, it's really hard, because you have to go again through everything, and you have to make sure that all the transitions are still there and still works. There is still no global picture of the whole flow, because again, only one state contains the next destinations, so there is no way to have everything described correctly. Business logic and side effects are inside the state itself, which makes it a little bit harder to test, because now we have a whole bunch of logic inside the same stuff. So now states are responsible for two things, the logic and navigation. So let's try to handle this, how to have this global picture of the flow and how to be sure that like, the concerns are really well separated, and how to have both worlds in the same framework or architecture. What I want in the end is this. I want the code version of this table. So I want to be able to read the code and say, OK, when I'm in the login from state, when I submit the thing, I want to go to loading. When I'm in loading and I have a success, I want to go to the profile page. Or if there's a failure, I want to see an error. Like, when I see this table is extremely straightforward and understandable to see what you have to do and what the code is doing and what the navigation is. So it must be a way to have the exact same thing, but in the code. And actually, Kotlin helps that a lot. How? With two features. The first one is that we can create functions that take functions. It's called higher functions in Kotlin. Jake Wharton did a really good talk about this, so you should see it if you haven't seen it. The second one is class extension. So now we can create extension on a specific class to add new functions. And these two features of Kotlin allows us to write pretty nice DSL. So again, this is about describing the flow. So what we want to do is a way to describe the flow in the code way. And DSL is for describe syntax language, which is exactly what we want. So we're going to start to write a DSL. So typically here, so this is an example just to make you understand how this works. So we have this. So this is like what we want to achieve. So HTML, title, body, whatever. So this is like a way to describe a page in the code. So when you read this, you know how the page is done. You don't need to understand what body means, what HTML means. You know that this page is like this. How do we do that? We create a class HTML with a title property and a function body that takes a function in other parameter, which means like body will take a function that allows you to create the body and the lambda after. In this case here, to have the HTML stuff at the beginning, we create a function HTML that takes a function as a parameter, which is an extension of HTML. So it allows you to do HTML lambda and then have access to the title property directly inside the lambda. So I will not go deeper on this, just like to give you the basics of what it is. But these two stuff allows you to create very nice thing in the code. So now let's try to see what our solution could be to manage all the problems we have, or at least I had at Shopify. Whoops, exit. Let's go to, oh yeah, that's gonna be hard for me. Let's try to do something else. No. Okay, that's fine. Oh, okay, where is my pointer? Is here. So the first thing we need to do now is, the first problem we need to solve is we said, okay, a state in the state machine, like a regular state machine, contains two things, the logic and the next destination. And we want to remove this from the state. And now what we want to do is the state, we want only the state to do something. We want the state to describe and say, okay, I consume this data. So typically for the email stuff is like for the check credential stuff, I will consume like an email and a password, and I will produce like something that will say, okay, now I'm loading. The login state will be, okay, now I'm consuming the credentials, and then I will produce either an error or an authenticated state, like I'm authenticated. So we want our state only to say, I consume this and I produce this, and I can have this error. What you do with that, how it's linked together, is not a state problem. So now a state is only this, so a regular state, which is a state that consumes here data, that will produce no error here, and that can produce all these actions. So typically here, it will produce the credentials. Because the regular state is like we are an empty screen, so we start typing our username, the password, and then we click sign in. And this produces the credentials that we will use to log in to be the person. The loading state is actually consuming credentials and will produce like either an error here or an authenticated account at the end of the loading state. And the error state can be like consumes a message, like an error, sorry, and it produces a message here, typically. So once we know that, the question is like, how do we link all of this together? How are we sure that everything is working correctly? And how do we describe and write our flow? And how do we have this diagram in the code? So this is actually, oops, sorry. It's not pretty. Yep. Whoa, I'm not seeing everything here. That's sorry for that. I'll try to see here. Okay, I mean, on the good one. Sorry for this. So let's focus on this class here. We don't care about this one for now. So this is, remember what we saw earlier, like the whole states we want to manage and all the loading stuff. So I type, then I click on submit, and I have the loading stuff, then either I have an error or I display the profile stuff. This is the same thing. I mean, everything in here is the flow you saw. So what we say is the same thing as the table we saw earlier. We say, OK, for the states, like the default state, when I'm clicking on sign in, then I go to loading state, and I use a check credentials processor to do that. I don't care about what this processor is doing. What I care about is how things are linked together. This is the whole point of this. When I type something, I want to stay on the same state, but I want to validate my fields using a transformation that says, OK, for these credentials, I want to be sure that it's valid. And what valids mean, we don't care, because it's not the whole point of this, right? We have functions that will take care of that. Here, the function is this one. The transformation here is this one. So this could be like a small function somewhere else that could be used as a dependency here of the flow. And so we won't care at all about what the transformation is and what the logic is. What we only want to do is how things are linked together. When I'm in loading states, when it's finished and we have an authenticated account, I want to go to the authenticated state, right? And if there is an error, I want to go to the error state. And that's pretty much it. And I could add something really easy, which say, let's say now I want to add like a logout button to say when I'm log out, I want to go back to the regular state. So it's pretty easy now because I can do that, first state here. First state, and I will say, okay, fine, let's add, which is like, I think it's authenticated state. Oops, with an H. Yeah, for this state. And when I have on this action, authenticated state. Oops, that's not the best thing to code, like by looking beside you. Okay, dot action. For this action, I want to go to the regular state here. Whoops, regular state. And that's it. And now I added a new transition very easily. And there is nothing more to do. And this is what I wanted to achieve. So here, we have, I don't know what the time I have. 5 minutes, amazing. So now that we have this, now we see like it's very easy to add new stuff. If I want to remove a state here, I can do it, and I don't care, actually, because this is the source of truth of my whole navigation stuff and what is happening in the app, which means like adding something new, removing something, swapping states is extremely easy compared to what we had so far. Now the question is like, how do we link that to the UI? Let's go to the activity. Activity. Hopefully, yeah, amazing. What I do is pretty much what we had so far with MVI stuff for the people who saw the talk. Is like we only observe the state that comes from the flow. What you've seen so far is called flow. It's what I wrote at Shopify. So we observe the flow, and we have the current state and an instance of the flow here. And what we do is only like, OK, when I'm in the regular state, I can have access to the data of the state here. And because of Kotlin, that say, OK, because it's the state, now data is, oops, sorry. I know the type, so I have access to my data here, credentials or is valid. And so I can display whatever I want to display here. Because I have access to the data directly. I don't need to try to check if I'm loading, if I'm not loading, what is the buttons, whatever. I have the data I want to display right here. For the loading state here, I know I'm in the loading state, so if I want to display loading, I don't have to check a boolean. I just have to, it just will display loading right there. Error state here, same thing. I have the data, and data is something different. Oops, sorry, it should be below. Whoops. And now we have the message we want to display. So we have nothing more. And that's it. And when we are in the authenticated state, then we have the data that is available for the next screen, which is here the access token with like the user information and all that stuff. It's not here, but it should be. But we have all the data we need to display for the next screen. So now we can call the next activity or the next fragment or whatever with the right data. And we don't care about what is happening and how we got this data. If I go back to the flow here. Now the question is like what is the processor then? The processor is pretty easy. Typically the check credentials is something that will call the backend stuff and return, like create a new action, which is in this case, creating a function in the state. So which is here, we do our check credential stuff, and then we call state.authenticated. And because this function is part of the loading state here, there is no way for us that we can call a function that does not exist. The code will not compile. So if we want to manage to create a new action that is not relevant here, it won't work, because there is no function available for this state. So that's fine. It's done. Any question? So let's go back to here. Oops. So yeah, so we basically actually manage all our problems. We have something that that allows us to write something like this, that allows us to find blocks easily because we have only states the same way. We have a global picture. The logic business is isolated. Side effects are isolated. We don't have to try to find the states by whatever booleans we have. And so all the problems are really solved. We can add new state very easily or remove one, and everything will either compile if it works or not if it doesn't work. So problem solved. Everything because of Kotlin. So there is no open source things yet. Whoops, sorry. So there is no open source things yet. It will come soon. The whole point of this stuff is like I didn't want to talk about it to a specific library that you could download or whatever. Everyone can do that. Like it took me a week to write it, right? So it's easy to write. It's easy to maintain, kind of. And if you want to have something like this, you can by yourself. If you want to rely on an open source project, I will also something new, but you can do it by yourself.